Right, hello there, geometry kids. We are back with a new lesson for Thursday. I did not explain very well the last time, but if I don't post something, like yesterday, Wednesday, I didn't post anything new, it's because I'm going to give you a little chance to kind of work on some things, because I know that this online thing is different. So, if you don't see something, don't worry, you didn't miss it. I mean, at least I don't think you missed it. You can just use that time to work on the homework I gave you or in a different class. You'll be getting new assignments like every 2 days. Um, I'll give you probably a video lesson and a new assignment. All right? Um, so we'll get into this one. This is section 2 in chapter 10 where we're finding arc measures. We're going to talk about how do you find arc measures. We're going to begin with a central angle. A central angle is an angle whose vertex is at the center of a circle. So, for example, if we have a circle, a central angle would be like that red angle because the vertex is at the center of the circle. Okay. A minor arc is the part of the circle measuring less than 180. So if I want to give you a little picture of that, so if we have a circle, a minor arc would be like this little blue part. It'll be less than 180, the degrees around the circle. And we're going to talk more about that as we go. So a minor arc is less than 180 degrees. A major arc is the part of the circle measuring between 180 degrees and 360. So I gave an example over here. We have a circle like this. The major arc would be part of the circle that is bigger than 180. So like that red part would be the major arc. It's a bigger piece of the circle. It's bigger than 180. Okay, and then there is a semicircle, which I can draw that down here. So if here's our circle, there's a center. If we have a diameter like that going through the middle, the semicircle is half of the circle. So what's in red right there? And many of you probably already know what a semicircle is. All right, and then how we name these things, we always name a minor arc with 2 letters. So it looked like this: measure of arc AB. It would have that rounded thing on the top. That's for a minor arc. If it's a major arc, we would use 3 letters. So this could be like measure of arc X, Y, Z. So major means bigger, so you have to have more letters. Minor arc would mean smaller, so just 2 letters. Right? And then congruent circles are circles that have the same radius. Congruent arcs are arcs that have the same measure, and they are in the same or congruent circles. And we'll talk just briefly about that. All right. And then last thing on the first page here. So measuring arcs. The measure of an arc is the measure of its central angle. So the measure of the entire circle is 360, which many of you probably already knew. And the measure of a major arc is the difference between 360 and the measure of the related minor arc. So the measure of a semicircle is half of 360, so 180. Okay, and notice we talked about major and minor arcs. The minor arc, AB, uses 2 letters, the major arc, A to D to B, in blue, that uses 3 letters. So that way you know which one they're talking about. If you just said AB, I wouldn't know if you meant like AB in the red or A to B in the blue. So that's why we have to use 3 letters compared to 2 letters. Okay, so a couple examples. Find the measure of arcs. Find the measure of each arc in circle C, where DF is a diameter. So find the measure of arc D to E. So you look right here, D to E will be that blue arc. The minor arc is equal to the central angle, so our central angle is 117. So arc DE is 117 degrees. If you want to find arc DFE, DFE has 3 letters, which means this is going to be bigger than 180. So D to F to E is in the red there. So what we're going to do here is take the entire circle, which is 360, and then take the only part that's not in red. So DFE is in red. The part that's not in red is right up here. This is 117 degrees. So we'll do 360, and we're going to take away that 117 degrees. So 360 minus 117. If we do that, we'll get 243 degrees. So notice that one had 3 letters, and it's 243 degrees, bigger than 180. Okay, and then lastly, we have arc DEF, which means you go from D to E to F. This is going to be the yellow part. So notice that this forms half of a circle. It's the diameter. So this is going to be a semicircle equal to 180 degrees. Okay, so one was a minor arc, part B was a major arc, and part C was a semicircle. Okay, I'll just go through the checkpoint quick. Find the measure of RTS. So from RTS, you go from R around to T and keep going to S. So if you look in that yellow part, the only thing not included in this circle that's not yellow is that small red part. So what we're going to do now is take the entire circle minus that small part, so minus that 45 degrees. So this is going to be 315 degrees. The yellow part's 315, the red part's 45, because together those form 360 degrees. Okay, postulate 23 is the arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the 2 measures. So if you want to find out how big is it from A to B to C, what you're going to do is take how far is it from A to B and add that to how far it is from B to C. So you're going to add up the 2 pieces. You're going to add up this red part with this blue part to get the yellow part. Okay, so example 2. Find the measures of the arcs. So the first one, we want to find out how big is it from B to D. So B to D is 2 letters. Notice we could go 2 directions. We could go this direction, B to D, or we could go this direction, B to D. Okay, what we're going to do, since it's 2 letters, is we take the shorter direction. So you take the shorter distance around, which is going to be from the left there. So to find the measure of arc BD, we need to know this distance. So there are two parts that make that up, 55 degrees and 105 degrees. So we're going to do 55 plus 105. This is going to be 160 degrees. Notice, two letters, less than 180. Part B goes from B to C to D. So that goes the long way around. So the pieces that make this part are 140 and 60. So to find how far is it from B to C to D, you would do 140. Oops. We'll do 140 plus 60. So how far is that one going to be? It's going to be 200 degrees. So three letters, it's going to be bigger than 180. Okay, and then our last part is we're just going to talk about how you can tell if circles or arcs are congruent. And we'll explain why or why not. So in A, tell whether the given arcs are congruent. We want to know, is arc BC congruent to arc DE? So is the blue congruent to the red? So if we look, they're both 75 degrees. And how else we can tell they're congruent is they need the same measure and they have to be in the same circle or congruent circles. So this one will be yes, they are congruent, same measure, same circle. This would be our reason. Same measure, same circle. Both 75 degrees, both in the same circle. And I like to think of these as like a pizza. If you had a triangle piece and your friend had a triangle piece of a pizza from the same size pizza, they'd be equal. But if you take a piece of a bigger pizza and your friend takes a piece in a smaller pizza, whose pizza is bigger? The bigger pizza, if that makes sense. Part B, is AB equal to arc CD? So clearly, both of these have the same angle. They're both the same measure. Right? They're both 80 degrees. But they're not in the same circle, and they're not in congruent circles. The circle on the outside, this red circle, is bigger than the circle on the inside. So are these congruent arcs? No. Same measure. Not same size circle. Okay, and if you are someone who is in track or familiar with the track, if you run around the curved part of the track, if you run around the inside lane and your friend runs around the outside lane around the curved part, who has to run further? Your friend does, because on the outside it's much longer to run around that arc than it is on the inside. Okay, and then the last one. How about arc FG and arc HJ? Are these congruent? So first we gotta check, are they the same measure? The answer to that would be yes, because they're both 90 degrees. And now these are clearly not in the same circle, but are the circles the same size? Based on this marking right here in yellow, that tells us that the radius, this part right here is called the radius. The radius of the circle is the same. Both circles have the same size radius, so therefore they're congruent. So are the two arcs congruent? Yes. Same measure. Which is 90 degrees. And then congruent circles. which means they're the same size. So they are congruent circles, which means they are the same size. So same measure and same size, so those are going to be congruent. We are actually going to stop right there because the last two problems are the same as what we've covered. Again, don't hesitate to ask me questions. You can send me an email and let me know what number you were on, and I have no problem making a quick video to answer your question. Pay attention, I might be posting some answer keys where you can check your work, or I might be grading it and just kind of giving you some feedback. So pay attention to that, and we will be getting back to you guys soon.